Hi all, in this video I'll be continuing the discussion on tutorial questions for subtopic 3.2, question 5, 6, 8 and 9. So let's get started. First question, explain the difference in radius between the ions and their respective neutral atoms. So what ions do we have here? We have Na+, which is smaller than its neutral atom, and we have Cl- chloride ion, which is larger than its neutral atom. So why so this difference? So let's look at the cation and its neutral atom. So firstly, as we can see, the number of electrons in both species is 10 and 11 respectively. Okay, so in sodium, since it has 11 proton, it has 11 electron. Now in sodium plus, we have removed one electron to form the cation, therefore the number of electrons remaining would be 10. Okay, and the next is, although they have difference in number of electrons, the number of protons is still the same. Okay, the electronic configuration of Na plus is 1s2, 2s2, 2p6, whereas the electronic configuration of Na is 1s2, 2s2, 2p6, 3s1. Thus, the effective nuclear charge of Na plus, okay, is higher than the neutral atom. Therefore, the attraction between the nucleus and the outermost electron in Na plus is stronger than Na, making Na plus smaller than Na. Okay, so sodium cation is smaller than its neutral atom. So what about chloride ion, which is bigger than its neutral atom? So anions, in other case, have more electrons than its neutral atom, because electrons are gained during the formation of an ion. So when you have more electrons, you will naturally experience greater electron-electron repulsion, okay, causing the electrons to spread out. So how can we say this electron is spread out? We can say the electron cloud is now larger, okay, or more diffuse. All right, so you have got a larger electron cloud. So when you have a larger electron cloud, you experience less attraction from the nucleus, hence chloride ion is bigger than chlorine chlorine atom. Okay, so explanation along that line lah. Right. Next would be question 6. Define the term isoelectronic, this is important, and arrange the following ions in the order of increasing ionic radii and explain. So we have all these 4 isoelectronic ions given to us. So let's arrange them. So firstly, what is the definition of isoelectronic species? It would be a group of atoms and also ions or ions with the same electronic configuration. So as we write the electronic configuration of magnesium, sodium and oxide ion, we see that they share the same electronic configuration. So all these 3 are isoelectronic. Whereas chloride, on the other hand, is not isoelectronic. Alright, it's okay, we can still do the comparison. As we can see here, chloride ion would be the largest because it has 3 electron shells. How did I know 3 electron shells? Because the principal quantum number is 3. Okay, so it has got high screening effect and the outermost electrons are attracted less strongly towards the nucleus. As for magnesium, 2 plus, Na plus and O2 minus, which are the isoelectronic species, you can see that the number of protons increase from O2 minus to Mg2 plus. Alright, therefore the effective nuclear charge would increase from O2 minus to Mg2 plus. Thus, okay, the outermost electrons in Mg2 plus are attracted more strongly compared to O2 minus. That is what is mentioned here. We have mentioned it such that the outermost electrons are attracted more strongly towards the nucleus from O2 minus and Mg2 plus. An easy way to remember this, as I told you in class, if all of them are isoelectronic species, the more positive cation, okay, will be the smallest, and the more negative anion will be the largest, okay, provided they are all isoelectronic. Okay, right. So let's go on to question number 8 now. So this is a graph given to you, and it's on ionization energy. Okay, so this shows ionization energy of atom X. The ionization number of the graph corresponds to all the electrons in atom X. So in total, we have a clear picture that atom X has got total 6 electrons. It's not the valence electron here, it's totally 6 electrons. Okay, so now predict the number of valence electron for atom X and give an explanation. So as we can see here, between ionization energy, the 4th ionization energy and 5th ionization energy, there is a big jump. So what does a big jump indicate? The big jump indicate that the first 4 electrons are the valence electrons, and the 5th electron, starting from the 5th, it has moved to inner shell. Therefore, the 5th electron is actually the inner electron. So as we can see, predict the number of valence electron. The valence electron is 4. Why? Because there is a drastic increase. The keyword that you have to use is a drastic increase in ionization energy to remove the 5th electron. Or in other words, if you have done the calculation, IE5 over IE4 would have given you the highest ratio. Alright, next, state the group of atom X since it has got 4 valence electron, and that would be from group 14. And finally, explain the trend. Okay, explain the trend in the increment of ionization energy as shown in the graph. That means we have to start talking about everything, okay, from the very first ionization energy. So let's have a look at that. So first ionization energy is the lowest because the first electron is removed from a neutral atom. Okay, fair enough. Then the second ionization energy until the 6th ionization energy gradually increases because each electron is removed from a positive ion. Okay, there is only a small difference in ionization energy between IE1 to IE4 because all the electrons are from the same shell. Okay, the 5th ionization energy is very much higher than the 4th ionization energy because the 5th electron is removed from the inner shell. In order to remove the 6th electron, energy needed involves only a small difference because the energy is removed from the same shell, n equals to 1. Now, a quick question. How do they know it is N1 and N2? Simple, because question already mentioned that only has got 6 electrons. This atom X only has got 6 electrons. So let's write an electronic configuration for 6 electrons. That would be 1s2, 2s2, and 2p6. So between not 2p6, 2p2. Okay, so the first 4 electrons, as shown, as proven by the data in the from the graph, we can see that it is in n equals to 2. And electron number 5 and electron number 6 comes from n equals to 1. All right. Okay. And for the last question. So you are given data for 5 successive ionization energies of element X, Y, and Z. Okay, so by using the ratio method, they have clearly mentioned, use the ratio method, identify the valence electron for each element. Next, identify the elements that belong to the same group and state their group, give an explanation. Write the valence electronic configuration for all elements and explain the difference in first ionization values for atom X and Y. Okay, let's do it part by part. So firstly, for the ratio method. Okay, so 9A, the answers are here. As you can see, when we compare the ionization energies, the successive ionization energies using ratio method, it's quite clear who has got the which ratio is off and where is the big jump. So here you can see that between the fifth ionization energy and fourth ionization energy, the ratio is very high. Therefore, there's the big jump lah. So number of valence electron will be 4. Same goes to Y. Okay, the ratio between IE5 over IE4 is the highest. It's not following the trend. So valence electron would be 4. And for Z, IE3 and IE2 ratio is the highest. Therefore, we can clearly confirm that it has 2 valence electron. Now, which two elements belong to the same group? That would be definitely X and Y, group 14, because they have same number of valence electrons. Simple. Right. Writing the electronic configuration for all these elements. Now, I've taught you this method in class, whereby when the period is not given, instead of writing a principal quantum number value, we include the symbol N. Okay, so that would be the valence electronic configuration for X, Y, and Z. And finally, explaining the difference in first ionization value of X and Y. Now, let's quickly look at the first ionization energy value for X and Y. So, first ionization energy for X is greater than Y. Okay, so here we can already start thinking that the valence electron must be closer to the nucleus in X than Y. Okay, because that's why the ionization energy is higher. So it's more difficult to remove the valence electron. Okay, so what's the answer given? The magnitude of the first ionization energy is related to the strength of attraction between electron and the nucleus, correct? Okay, so magnitude means the size of, the size of ionization energy. Okay, so if higher the ionization energy, it's not size, sorry, it's the value of ionization energy. So if the ionization energy is high, that means the force of attraction between the electron and the nucleus is strong. So since the first ionization energy of X is higher than Y, that means X is smaller than Y. Okay, so that's why I mentioned over here the distance between the valence electron and the nucleus must be closer in X than Y. That means X is smaller than Y. So since X is smaller, the stronger the attraction force between the nucleus and the valence electron in X compared to Y. Alright, so those are the things that you have to rationalize when it comes to questions like this. Boleh? So I hope you have done it, you have checked it now, and you will submit it next week. Thank you.